Hey, what's going on, guys? Mr. Flores here, and this video is going to be dealing with solving inequality word problems. Alright, now, solving the inequality part is easy. Setting up the word problem, not so easy. But I'm going to try and break it down as easy as I can to make it as fun as possible. And that's an oxymoron for some of you. But anyways, the first word problem we're going to do deals with a bank account. Alright, this is realistic because when you're a teacher, like myself, some districts don't pay you in the summer. So you're going to have so much money in your bank account, you got to budget, figure some things out so you don't go broke. And that's really what this problem is dealing with. So it says that Alex has $1,000 in his bank account. All right? $1,000 in account. All right, he wants to have at least $300 in the account before he stops taking money out. How many weeks can he withdraw $50 before he reaches his threshold? All right. So I want to have $300 at the end of X weeks of withdrawing $50. All right. So basically, with the inequality, there's two sides. The left side is going to be money in account. Okay. The right side is going to be the threshold. I don't know why I couldn't think of that for a second. All right. So money in the account. The money in the account, well, we first start off with $1,000. Okay, but if you notice, every week I'm withdrawing $50. So it's 50, but we don't know how many weeks it's going to be, so it's 50x, because this is the money that starts in the account minus $50 for every week. Then the threshold is I want to stop when there's $300. Now it says I want to have at least $300 in the account, so really the way our inequality symbol is going to be is we need the money in the account to be greater than or equal to 300. And that's where a lot of people get tricked. Or not a lot of people, but more, well, yeah, people get tricked because even adults do this. They don't really know which way their inequality symbol is going to go. But if you turn your sides of the equation into words, as in money in account and threshold, it makes your life a lot easier. All right? So now all we have to do is solve this. We want to get the x all by itself. So we have negative 50x over here. We want to bring this 1,000 to the right side by subtracting 1,000. So you get negative 50. X is greater than or equal to negative 700. All right, divide both sides by negative 50. Divide by negative 50. The rules of exponents still stay true. So when we divide by a negative number, you must flip your signs. And x must be equal, x is less than or equal to 14 weeks. Okay, so as long as I withdraw $50 a week for 14 or less weeks, I'm still going to have at least $300 in my account. Okay, so the answer to this one is x is less than or equal to 14 weeks, or I can take money out without putting any money in for up to 14 weeks. Again, solving the inequality was very, very simple, but setting it up was the difficult part. But as long as you start with words, it makes it a little easier. This next problem is probably my favorite type of inequality problem, just because it directly pertains to you guys in school. All right? So it says here that Jill's taking her last and 6th tests for the marking period. So far, her test grades are 96, 85, 94, 89, and 88. What must she get on her last test to get at least a 92 in the class? Okay, so again, we're going to write our inequality in words first. So one side can be grade in class. Okay, she needs her grade in class to be at least a 92. So we want that number to be greater than or equal to 92. All right, so grade in class greater than or equal to 92. Except now we have to find some equation for this grade in the class. All right. Now, what we have to do here, though, is you have to think to yourself, how do you find the average of something? Now, the average is you add everything up and divide by how many there are. So for our grade in the class, we're going to add up all of our test grades. So I'm going to grab 95 plus 85 plus 94 plus 89 plus 88. So right now in the class, she has 452 points. The only thing is, she's only taken 5 tests so far. We need to find out what can she get on her last test to get a 92 in the class. So since we don't know what her last test grade is, we can do 452 plus x. All right? Because she has 452 points so far, we don't know what she's going to get on her last test, so you add x. Then you divide that by how many tests there are, which in this case is 6. And that has to be greater than or equal to 92. All right, this here is just the grade in your class. You add up all the test grades, divide by 6. When you add these 5 up, you get 452. Well, you must add x because we don't know what she got on her last test. And again, you just solve this inequality like you do everything else, like every other inequality. So in order to get rid of the 6, you multiply both sides of the equation by 6. So you're going to get 452 plus x is greater than or equal to 552. All right. In order to get x by itself, we must subtract 452 from both sides. All right. And you're going to get x is greater than or equal to 100. So now x stands for the last test on her, the last test in the marking period. So in order for Jill to get a 92 or an A in her class for this marking period, she must get at least a 100 on her last test. So in order to really answer this question correctly, to get full credit, you must put she needs at least a 100 on her last test. You need to take this inequality, answer solution x is greater than or equal to 100, and turn it into words that mean something to the normal person, just so you know that she needs at least a 100 on her last test. Good luck to her, because that's tough. But that's how you solve this problem. Again, the thing that's difficult in both these problems is not solving the inequality, but rather setting up the inequality. All right? But as long as you break it down, should be pretty good. Last one. Your elementary school is having a fall carnival. Admission into the carnival is $3, and each game inside the carnival costs 25 cents. Write an inequality that represents the possible number of games that can be played having $10. What is the maximum number of games that can be played? All right. So here the inequality is money in pocket. We need that to be greater than pocket. We need that to be greater than or equal to money spent, because you can't spend more money than you have. All right. So again, basically, this is the hard part, setting up this portion of the inequality. What's on the left side? What is the right side? But nicely, the left side is the money in your pocket. So how much money did you have to begin with? 10 bones. The right side of your equation is a little trickier. All right. Admission into the carnival is $3. So right off the bat, you're spending $3. Then you're spending an additional 25 cents for every game you play. We don't know how many games you're going to play, so little hint, that's going to be our x. So we have 10 is greater than or equal to 3 plus 0.25x. Now that's all that we have to do for this problem other than solve it. So if you want to get the 0.25x by itself, subtract 3 from both sides, you get 10. Oops, you don't. That's a lie. You get 7 is greater than or equal to 0.25x. Divide both sides by a quarter. And you get x, you get on the left side, 28 is greater than or equal to x. So you can play up to 28 games. 28 games with 28 games spending all your money. Because it says right inequality represents the possible number of games that can be played, $10, which is this. Then it says what's the maximum number of games that can be played. We can play 28 games because as long as you don't play more than 28, you can't play more than 28 because x has to be less than or equal to 28. All right, so that's this inequality. Again, solving these inequalities are not difficult. but setting the inequality up is the difficult part. Make sure you read the inequality, really understand what are you looking for, all right? And that's the best advice I can give you. Read them very carefully. If you have questions, let me know. Check out the website, email me, ask questions. I hope you enjoyed it. Hope you learned something.